Now in this video we will study about the rules for calculating cell potential, how we can calculate the cell potential. So this is the very important formula, you have to memorize this one. E standard cell potential will be equal to E reduction potential plus E oxidation potential, or we can use this E cathode or E anode, and usually we have to given that only reduction potential, and if we have to find out the oxidation potential it would be reverse of the sign. And the most important thing is this must obtain plus E cell potential. So it means the final E cell must be positive, since the potential in the table are written as reduction potential. The reaction need to be reversed in the case of oxidation. So basically they are talking about this table. So in this table you can see all the potentials are written in the reduction potential, and if we have to convert any one in the oxidation potential we have to change the sign. Plus will become negative and negative will become plus. And second rule is that multiply reaction coefficient as needed to make electrons cancel out. Do not multiply E0 cell. This is very important. Cell potential is intensive property. It means it does not depend on the amount. So for an example, if we have zinc 2 plus aqueous plus 2 electron, if we have written like this one, that reduction potential for the zinc solid is E cell of reduction potential for this is negative 0.76 volt, and if we multiply this reaction by 2 zinc 2 plus 4 electron 2 zinc solid, then E cell potential, E reduction potential for this reaction, even after multiplying it will not, we need not to multiply this one, it still will remain the same value 0.76, right. So whether you do one time reaction, whether you do 100 time or million time, E reduction potential don't change. So that is why it says that multiply reaction coefficient as needed to make electron cancel out. Do not multiply E cell potential because it is an intensive property. Add potential for the half reaction to obtain cell potential. So we, as we have seen in the previous slide, that we have to add these two potential to get the final cell potential value. So these are the three important rules we will follow to calculate the reduction potential. And next important thing is this, that once we are going to calculate E reduction potential for the galvanic cell, we have to find out that how do you predict which reaction is happening at the anode and at the cathode. So for an example, as we have seen in this table, that there are many reaction, all the reactions basically written in the reduction half potential, and if we have to make a galvanic cell from zinc and iron or silver and zinc or copper, so how do we know that which reaction will be at cathode and which reaction will be at anode? So how we can predict the anode and cathode in the reaction? So a cell is always run spontaneously in the direction that produce positive cell potential. So one thing is important, whenever we will calculate the CE cell, that must be at the end must be positive. If you are adding reduction potential and oxidation potential in such a way that E cell is coming positive, then it is correct, and if it is not coming positive, it means there is something wrong. So, let us see one example to understand this galvanic cell electrode determination. So, how we can determine the electrode? So, determination of electrodes. For an example, if there is a there are two potentials are given. So, usually more positive are written on the top and less positive or more negative reduction potential written at the bottom. Basically, we are talking about this table. So, here you can see more positive on the top and more negative at the bottom. And if we are using any of these two reaction, how we will figure it out which will be anode, which will become cathode. So, what we have to figure it out, what we have to remember that this line says that strongest oxidizing agent on the top. It means they oxidizes other metals very easily and they reduce very easily. They reduce very easily means they can gain the electron very easily. On the bottom, the most difficult to reduce. It means they have hard time to gain the electron and they oxidize, they are weakest oxidizing agent. So, we will follow this rule to apply here, that if we see more positive or bigger value, basically bigger value, if we are comparing two positive or two negative, then I will say the bigger value will become cathode or reduction will happen on the bigger value of reduction potential, and more negative or small value where the oxidation will happen and that electrode will become as a anode. And once we are going to calculate, so we will calculate using this formula, E cell equal to E reduction plus E oxidation, or we can utilize this equation, E cell equal to E reduction of cathode minus E reduction of anode. So, here we are not going to convert E reduction into oxidation, so we can use as such. So, let us take one example. For an example, if we are comparing if we are making a galvanic cell using copper and zinc, so first we have to write down what is the reduction potential for copper. So, copper reduction potential is plus 0.34 volt and zinc reduction potential is minus 0.76 volt. So, here you can see this is the bigger value, this is the small value, basically more positive and less positive or more negative. So, we can calculate the E cell for this galvanic cell in the two ways, number using either this formula or this formula. So, let us calculate the E reduction potential using this formula first. So, E cell will be equal to E reduction for cathode and plus E oxidation for anode. So, you can see that more positive will become cathode and this will be reduction will happen here, and more negative will become anode or oxidation will happen here. So, I will add 0.34 plus sign for this one, for cathode will remain same, but for the oxidation I have to change the sign. So, this negative sign will become positive and then I am going to add E cell. So, this will give us positive value of E cell 1.1 volt. Another method we can utilize this formula, E cell equal to E reduction of cathode minus E reduction of anode. So, let us use this one. So, E cell is first for cathode. So, cathode is here copper and copper value is plus 0.34 and then minus, then we will use without changing the, basically we are subtracting the reduction potential from cathode to anode. So, anode potential is negative 0.76. So, once we will open the parenthesis, this will become plus and you can see the E cell will become again plus 1.10 volt. So whether you use this formula or this formula, you have to use this rule that more positive will become, or bigger value will become cathode, and small value or more negative value will become anode, and then you can do the math. So this was in this way we understand this what are the rules to calculate the E cell potential, and how we can determine the two electrodes, whether which one will become cathode, which one will become anode.